All right, welcome everybody. Travers, I looked this up before. It is episode 48.
We're sure this time.
I'm sure. I've triple checked. I actually went through and counted all the blog posts. It's 48. So it's 48. Awesome. It's another Wednesday night, and we are joined by a couple guests this week, which I'm going to let them introduce themselves in a minute. But Mike Carter, I didn't give you the other scoop. When we generally start this, we try to just have some intro talk, and it ends up usually just devolving because neither of us really think about it beforehand. We'll make some.
You would think
some
50
comment.
episodes in, you'd figure it out, right?
Yeah, we figured it out. We don't really have a real intro. It's just like, hey, it's Wednesday, and we usually talk about something, and it usually just revolves around weather because the weather where we are has been not great for the end of May. But I actually have something interesting to start the episode, completely unrelated to what we're going to talk about. Okay, so I got to give you the 5-second backstory. My wife's out running errands, I don't know, last week sometime. She comes in and she says, I don't know what it was, but there was a huge bird flying around the neighborhood. And I was kind of like, oh, huge bird, that's kind of cool. And I'm like, is it still there? And she's like, no. And I'm like, okay, well, great story. So the other day, I guess it was this week. It was earlier this week. I'm standing out in the front lawn, and you know when you just see something in your peripheral vision? And I just thought it was like a squirrel or something. So I turn around and look, and I'm like, there's nothing there. And then I see a huge, and I'm not exaggerating, a huge shadow go across the street and then like up the side of my neighbor's house. And I'm like, what is that? So I wander out, and it is a bald eagle. And I mean like,
no way.
I mean like a huge bald eagle. And we stood out we stood out on the street. I'm sure if any neighbors were in their house looking out their windows, they were probably like, what is that person doing? Because I was just standing on the street, like going like this, right? Like looking around. And this thing was
like your heart, like
it was huge. And I live.
No, we don't do that here.
Yeah. Travers, you know me. I live in a subdivision. I've lived here for more than 20 years. You don't see.
Yeah, you're in Oakville. That's bizarre.
That
guy was
like,
lost.
Yeah, and he was literally just doing loops. I swear, my wife and I were laughing. He was just going backyard to backyard to back. He was just working down the block and then up the other way. And I'm like, oh, man. Secure your small children and pets because that thing is large, right?
I was going to say, if you had a rodent problem before, you sure don't now.
Yeah, he's doing you a favor. He's cleaning it up. So that is our completely unrelated story to start the episode. I saw a bald eagle. Who knew?
Congratulations.
Yeah, right? Maybe it's an omen or something. I don't know. Hopefully a good one.
We don't quite have the bald eagles, but we do have like a cabal of blue jays in our backyard.
Yeah.
Because we feed them.
Oh, do you?
Yeah. So it turns out, so my wife's really into birds. She goes like really deep on topics. Like last month it was gem cutting and faceting. Now it's birds. So she's really into birds. And apparently blue jays love whole peanuts.
Yeah.
Because they're kind of like, for two reasons. Like one, they're kind of a puzzle, right? Like, you put them in a cage and they'll come and they'll like pick them out of the cage and they got to like figure it out. Yeah. And sometimes they'll like test them. They'll like pick it up in their beak and shake it around and just be like, okay, no, this one's like too light. It's not worth it. I'm going to pick another one and they'll like throw it away.
Yeah.
And then also they cache them, right? They cache them all. I learned this the other day. An individual blue jay can have over 1,000 individual caches of food scattered around a neighborhood. And so we've got a cabal of like 8 of them will like rotate, and they'll form like a queue. And it's like there's going to be one on the feeder. There's one on the feeder like pole. There's one on the railing next to it. There's one on the branch above. And then there's one on the tree over. And then 3 kind of waiting in the wings. And they'll literally rotate. One will grab one, go off. The next one will hop over. The next one will hop up. And then by the time the last one gets up, the first one's back again after, one of its
stashed it somewhere.
Exactly right.
That's hilarious. They're well-behaved blue jays. Who knew?
They're like well-oiled machine.
Yeah. Yes, yeah. They have their system. That's great. All right, guys. Let's get kicked off with a quick intro. Mike, could you get us started just so everybody knows who you are?
Yeah, super simple. Hi, everyone. I'm Mike, and I'm the CEO and one of the co-founders of Modulate AI. We're frontier builders of cutting-edge AI models for voice understanding. Carter?
Awesome. Yeah. So I'm Carter Huffman. I'm the CTO and the other co-founder. Yeah, we're frontier builders of voice AI models.
Perfect. Well, welcome, guys, to the show. I bet you didn't think that you were going to come on an AI/AWS podcast and talk about birds.
I know.
You're a founder and you're ready for everything, but no, I didn't expect that.
I had the Blue Jay story ready to go. I was like, I bet that's going to come in handy.
Yeah, you never know. You never know. I do tend to throw curveballs. It's kind of fun. So thanks, guys, for joining us. I know we had a false start. I think it was last month, right? Trying to get all this scheduled, but it's great to have you both on the show. And I know that I'm speaking for Travers here. I think we're going to have a great conversation on various topics. I think for me, probably the best way to give us a little bit of background is just your origin story. I know you've kind of had a couple iterations as you started the company, and you've kind of gone through a couple, I'll call it pivots. Why don't you walk us through those so we can kind of just set the table for the rest of the conversation?
Sure. So Modulate started when Carter and I were undergrads at MIT. I was walking down the hall and saw someone working on an interesting looking physics problem. So being an MIT physicist myself, I mustered up all of my social courage and I stood awkwardly behind him for a few minutes until I found his missing minus sign. And that's how we became friends at MIT. We quickly found, hey, we work well together. We get how each other thinks, but we operate very differently. I am extremely distractible. I'm sort of the breadth person who's doing 7 different things at once, but I can think about a really big system. Carter is sort of the tunnel vision, but also if you give him an unsolved problem and a pizza, he will come back 3 days later and have solved the problem. So like very, very powerful, but very focused. So we felt like there was sort of a natural balance there. And like many college kids said, hey, let's go build a company. We had no idea what we were doing. We had no idea what company to build. So we prototyped a couple in college, had no idea what they were sort of going to be, didn't love any of those ideas. But by the time we graduated, kind of knew we wanted to find something that would resonate. Carter, being the tech genius, would obviously be the CTO. So I guess that makes me the CEO. So I kind of graduated and went to learn about different kind of company cultures, worked under a couple of serial entrepreneurs to see how they built companies. And meanwhile, Carter went to NASA's Jet Propulsion Lab as a machine learning scientist. So Carter, maybe you can pick up from there.
Yeah. So I was out there for a couple of years, and I was working on some really cool stuff. It was like spacecraft being able to do autonomous science. So like you're doing a flyby of an asteroid or something, and you might be like a whole light hour away from Earth, and that flyby is going to last 15 minutes. And so if you see something cool on that asteroid, if you try to ask Earth, what do I do? Should I like take another picture or something? Like by the time Earth gets the answer back to you, you're already gone. And because space missions are so expensive, like nobody's ever coming back to that asteroid ever again, right? So like the opportunity is entirely lost. So I was working on a lot of like kind of low power, really efficient, really fast models that could find interesting stuff in a lot of these signals, these measurements that the spacecraft were taking, so that if they could find something interesting, they could take an additional measurement of it while they were there and maybe get some extra science out of it, right? And like maybe is way better than 0% chance. So I was working on a lot of that, and a lot of that involved like a ton of signal processing. And again, as I mentioned, like really fast, really low power algorithms. And about the same time, this was around 2014, 2015, there was a lot of cool work in frontier AI coming out around kind of generative models before we really called it Gen AI. So adversarial image generation was kind of a big deal for a little while. And what it basically did was it allowed you to semantically manipulate images while still producing high quality results. So you could take a picture of me and then you could like subtract glasses and you would get me without the glasses and it would give you a reasonable result. And like nowadays people are like, oh yeah, you just put that into Gemini or ChatGPT and they'll do it. But like back then this was like a super big deal. And I was like, I really want to work at this, but like I don't work at Google. And I'm not, doing my PhD, and I got like really burned writing academic papers, and I'm like, I never want to do that. So how do I contribute to this. And there was kind of a really cool convergence of a couple different factors. One, kind of a lot of the physics background and signals processing lends itself to like mathematics on waves and different like frequency representation of waves, like spectrograms and stuff like that. And so like audio has always been kind of a very natural domain. And the other interesting thing is that in all of AI, and this has like always been true, voice is kind of last. Like everybody does like images because you can print in papers really easily, right? And then after images, you do video. Of course you do. And then people have gotten really into text lately for some reason. But you know, like voice has always been the last thing. But you know, we kind of like had all these really great mathematical tools to manipulate voice, and I was like, okay, well, what if I tried to take that adversarial training idea and apply it to voice? Like, what's the voice equivalent of like taking off my glasses? Like, what is that? And what Mike and I came up with was, what if you like swapped out your vocal cords as you're talking in real time and like, you know, shifted your vocal profile so that I could sound like Morgan Freeman or Taylor Swift or somebody, you know, while I'm still talking. And we started working on that for a couple years. It was really, really difficult at the outset, and I can talk forever about why voice AI can be trickier than images in some ways. But eventually we started making it sound pretty good. And we got together and we're like, hey, like we should move back to Boston and start a company. So that was really kind of the origin story.
Yeah, very cool.
That's awesome. It makes total sense, right? Like voice has got to be really rich data. You've got like tone and pitch and all, and let alone the word content that you're analyzing, right? That's yeah.
Exactly. There's so much to it, and also like, you know, it's kind of interesting as a media type is when you're generating voice. Like if you're generating an image of a face, like people can see a face in anything. Like you don't have to do a good job.
Right.
If you make a mistake, it doesn't matter. You'll see a face.
It's forgiving.
Yeah, it's very forgiving. It's very, and like now generated faces are really good, but like they could, you know, you can start out with like some defects and then build up to it.
A few extra fingers, yeah.
Yeah, right, exactly. Like whatever, 4 fingers, who cares, right? Like, you know, do you even pay attention to the hands? Like, but voice has a really, really broad uncanny valley. If there's something wrong with someone's voice, even if you can't figure out what it is, you're going to notice. And there's like a cool evolutionary argument to that, right? Of just like, if you're sick, it presents through the voice, you know, that kind of thing, or what have you. But if you generate a voice perfectly naturally, people pick up on it and they hate it. And so you have to like if you're developing voice tech, you're like, wow, I made so much progress. And then people listen to that and they're like, wow, that's shit. Like it's really bad. And then they're usually polite about it. But we did that for basically a decade. And it's just like, wow, we're making so much progress, but like it doesn't matter. 0, 0, 0, 0, 0. And then when you're good enough, you're 200.
That's hilarious. You reminded me of something. You know, I have an Echo on my desk, right? And they've recently changed the voice on it. And you made me think of it because you said people either like it or they don't like it. There's no in between. And I got to say, I don't notice it at all. But my wife is like, I don't know what's happened to this thing, but I hate that voice. And even my parents, they have one now and the exact same thing. So you're right. Like audio is so important because it's either good or it's not. And people have a real reaction to the audio, right?
And there's a ton of different nuances to this, right? Like if you listen to a professional, like celebrity impersonator, they never actually have a similar voice to the celebrity they're impersonating. It's all the idiolect, right? The pauses, the intonation, the style of it. And that causes you to kind of psychologically believe that they sound like the person. But if you then actually sort of listen closely, it sounds completely different. Yeah. Whereas on the flip side, if you give someone a new set of vocal cords, depending on they sort of use those vocal cords, they can sound very, very different.
So, you know, if I suddenly had a set of female vocal cords, the way that here can come across as a much younger person, or if I'm speaking much slower and I'm saying things like, hello, dear, how are you? Then suddenly it sounds a lot more elderly. And you actually see that manifest very much in the level.
It's pretty amazing time to be alive. I don't care what anyone says. To be able to do that, right?
Yeah. That was actually how we raised some of our early funding. Is I would pick up a phone call from investors using that voice and say, "Oh, I'm sorry, Mr. Pappas is busy. He'll be there in a minute." And then I'd come back over. I'd walk them through the pitch. They'd say, "I don't know if you can really make that tech work." And I'd say, "Oh, really?" And switch it back over.
No
And
way.
they'd say,
I love it. That was me the whole time.
Guerrilla marketing. That's crazy.
You know what? One of the funniest things about that, especially early on when we were building that tech, is like it's generating the sound of a human voice, like the human voice you're trying to sound like, right? And like you speak into it, and it's trained to convert a human voice to a human voice. But the only thing it knows how to output is a human voice. And so what if you input something different, right? Like we tried taking calls from like a cafe or something like that, and you've got like a car driving by, or you've got like air conditioning noise. And of course, the only thing it knows how to produce is a human voice. And so you would be on the other end of this call, and you would suddenly hear like, la, 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 and it's like, right?
It's interpreting the background noise.
It's like, or like a car horn would play, and it would be like,
Yeah, the things you don't think about until you actually try it, right?
Yeah.
And see what happens. It's neat.
So you tried passing any other kinds of time series like audio data to it, or any other time series data? Like,
we messed around with a couple of different. It was all usually in the audio domain, but we thought about like what would it be if like instead of swapping out my vocal cords for that of like a female voice actor, I swapped them out to like the timbre of a car horn. Like what would that mean? Probably it would be really abrasive, but we explored a lot of stuff like that. The first business cards Carter and I ever printed actually had our voices like printed on them as effectively almost a QR code, but like here's the like contained encoded information in our voices that our model would actually use to reproduce them. We just thought that was a cute little Easter egg as a sort of graphic on there.
Yeah, that's really cool. I guess the other thing that you guys are making me think of, like you mentioned, Carter, like voice is always kind of last, right? And I wonder here, like as sort of a category, right? Voice AI models as a category, it is like, can you tell us a little bit about sort of, because it's last, what does that category look like right now? Like, what are people doing? Where do you see this going in the future? Like, what other opportunities do you see around what you can do with these models now that you've sort of developed your first set of them?
Absolutely. So it's kind of a really exciting spot in voice. Like one of the nice things about, voice AI always like having, like some of these extra difficulties, some of these extra challenges, is that you can kind of see how powerful it can be after you get through those challenges, and it's really motivating. I don't want to sound too much like an investor here or something like that, but like voice AI is like in the pre-chat GPT like chatbot era. Right? It's like you can see the potential, right? Like, or maybe like GPT-2 or something, and you're like, wow, I didn't know it could produce like whole sentences with commas and everything. But before you could actually like chat with it, and you're like, wow, it passes the Turing test. It's like voice AI, you can see, wow, this is cool. We haven't really been able to do this before. But it's not, it hasn't like climbed that peak of usefulness. It hasn't like gone up that step function yet. And so it's actually kind of really interesting. Why? Because if you think about like what are the top use cases for voice AI, like the number one thing you think of is just like a voice chat bot. So you just like talk to it, and like maybe over the phone, like maybe a call center, maybe whatever, maybe just a friend. But like, a variety of just like, hey, just talk through your voice at a chatbot and it'll talk back. And it's like, okay, well, that's super easy, right? Like you just transcribe what you're saying, and then you put it into ChatGPT, and then you get, the result back from text to speech, and then you can just talk to a chatbot. And it's like how can that not work? And the shocking thing is that doesn't work at all, because like there's a couple of reasons. One is that latency is crazy important. So the like voice changing models that we started out with, the voice skins, our first version of that had 20 milliseconds of latency. And the reason it had that small amount of latency was, one, because if you're having a voice conversation, like the average latency in a voice conversation between when I stop talking and when you start talking is 0 seconds. It's not like 100 milliseconds, not like 10 milliseconds. It's like instantly you start talking the moment I stop talking. And then when you stop talking, I start talking, and we're just going back and forth very, very efficiently. And any delay that you add into that degrades the quality of experience. And like if you're trying to talk to an LLM, like it only really starts generating a response after you're done talking. So that has to be lightning fast. Transcription has to be lightning fast. Synthesis has to be lightning fast. And that's even to just get the latency down. But if you use models that are that fast, you have to use the light or flash or mini versions of your LLMs, and you can't use the biggest transcription models, and you can't use the biggest synthesis models. So maybe you're having a fast-paced conversation, but it's really stupid, and then you don't want to have that conversation anymore anyway. And so
it's like talking to your desk. You're like, I'm not enjoying this. I'm going to go do something else.
Exactly, right? Yeah. It's just like, just give me the phone tree. Like, how many times have you thought that? Even recently, post LLMs, right? Like, how I just give me the phone tree, like whatever, right? And so the latency induces constraints that aren't just, can I make this algorithm fast, but like actually affect how smart the experience is in a way that chatbots don't. And then the second challenge is that voice contains so much more information per sort of like unit of conversation than text does. Like when I code with Claude Code, I like write a 5-paragraph essay for my spec before we even start chatting. And I have a lot of time to think through like what's the appropriate way to engage with it next. Like you can be very, very efficient and pack a bunch of information in there. When we're having a conversation, like I say one sentence and that conveys a ton of stuff, and then you say the next sentence, right? And like we're going back and forth, we're packing a ton into that. And it's not just the words that I say, it's the emotion, it's the tone, it's the cadence, it's everything. Like you can tell I'm excited. You can tell if over the course of the conversation I was excited and now I'm not. And that means something, right? Like, and all of that meaning we react to as humans, and we expect the person we're talking to react back. But that transcription to synthesis pipeline that I was talking about earlier, that doesn't really have a good way to react to that and incorporate that information just from like a transcript. And so it behaves inappropriately, and you just once again feel like you're talking to a computer instead of talking to a person.
Yeah, that latency thing, I hadn't thought of that, but if you're like me, like the latency would also make certain people uncomfortable in a conversation, because it's like you said, it's unusual if you finish talking and then there's a pause, right? And everybody, like most people, I don't say all, like my personality would be to fill that space, right? And then as I try to start filling that space because I'm uncomfortable with the latency happening in the conversation, then you probably end up getting the response back, and it feels like you're then talking over each other, and it just continues to degrade that experience that you would have. It's like you said, it's got to be incredibly hard to make this not bother people, right?
And again, when you do it that fast, then you have to choose the faster versions of the models, which are the less powerful versions of the models, and then it's dumb, and then people talk to it and they're like, wait, I've like typed at ChatGPT before, it's so much smarter than this, and you're trying to be there like, yeah, like look, I've got constraints, right? Like but people have these really high expectations from text that are very, very, very hard to meet in voice. But like we can see how that would work, right? We can see how that would be possible, but it's just not there yet.
It's like, how do you solve that problem, right? I guess you have to consume it as a stream and update as you go, right? Or you just have to get really fast at processing.
Yeah, I mean, part of it is the speed. Part of it is knowing what to process in the first place. Like as Carter sort of mentioned, a lot of what's happening with other systems out there is this flattening of voice being converted to text, and so you're throwing all the good stuff away. A lot of our focus is how can you actually maintain the relevant information about all of that good stuff so that you can understand the conversation more holistically. And we kind of jumped around, so we sort of missed that. At one point, Modulate's sort of early focus was actually in the online gaming industry, when we were providing the AI models that power content moderation for Call of Duty, Grand Theft Auto, a bunch of these titles. it turns out when you need to tell the difference between, a couple of 13-year-olds just screaming at each other but having a grand time and someone actually harassing someone, like, you really need to understand the subtlety of what's happening in that voice conversation. Just reading out, oh, they said the N-word is not going to tell you enough about what's going on there.
I'm
Talk
laughing
about a rich data set.
Yeah, I'm laughing about that because my nephew has been bothering me to play DayZ for a long time. So I've had it in my Steam library for a long time, and I finally broke down on the weekend. I'm like, I'm gonna try this thing out. It's not my kind of game, but I'm gonna try it out. And I don't know if you guys are familiar with it, but it's a survival game. You got to kind of gear up, and it is probably. Well, Battlefield would be up there too. Probably one of the griefiest games I've ever played. Anytime you came across a human, there was a fair amount of smack talk happening, but it's part of the game, to your point, right? Like, is it harassment? I guess that would be sort of for each individual person to determine how they feel about that interaction. But if you're building software to try to determine that, I can imagine how hard that would be, because it would be very specific to the style of gameplay that people would be used to in that game, right? Like how people talk to each other in DayZ is probably much different than how people might talk to each other in, I don't know, I can't think of the exact opposite of DayZ. Mario Super Kart, maybe? I don't know. Maybe that could probably get
Mario Kart Online.
Maybe that could get quite feisty. I haven't.
But no, so that, like, yes, that's exactly it. And so, like, that, the cool thing is that extends. It's not just in gaming, but it extends to all these other use cases too. So our first use case outside of gaming a couple of years ago was in the fraud space. And you can apply similar lessons, right? If someone hops on the phone and says, oh my gosh, I'm so sorry, I just need this to get done today. My baby's screaming in the background. I'm about to go on vacation, right? Like, it's intense. You're trying to, elicit these strong emotional reactions from the agent.
Right.
If you can listen to the audio and say, hey, by the way, that's not a real baby. That's a recording of a baby playing in the background. Suddenly, that entire conversation takes on a very different meaning, but it requires you to understand the audio again, right? You can't tell intent. You can't tell that something's amiss just from the words being said much of the time. And even when you can, that subtle tone of, sarcasm versus sincerity can completely transform the meaning of the words being said.
Yeah, you're so right. Like sorry, Travers, just one sec. I was just going to say, like, just the tone in the conversation, like how that person is using their words, right? Probably can infer way more than what they're actually saying to that other person on the line.
Yeah, like, who hasn't had the experience of being texted by a friend and just saying, like, I have no idea if this is passive aggressive or supportive or what, because it's in text, right?
Yeah.
Or from your co-founder, it's funny that you mentioned that, because, like, that's how we actually got from gaming into the fraud space in the first place, and then started expanding all the way out, because we had a kind of food delivery company actually, like, reach out to us and say, hey, like, saw your Call of Duty case study. Like, you find when people are threatening to, like, kill each other for real, not in game, like, and you find these threats of violence. We actually have a really interesting use case I wonder if you can help us with, where, if somebody's delivering food to somebody's door, like, you can, sometimes you can, like, call the delivery driver and just say, like, hey, like, this is the code to the lock, or, please just bring it around back, or something like that. And occasionally you get people who call the delivery driver and are, like, really angry, right? And they're like, I am so, like, upset at you for being late. Like, where are you? Like, this was supposed to be here 10 minutes ago or whatever, right? They're super hangry. And occasionally that will turn into threats. And because you're delivering something to their door, you're going to potentially meet them in person. Most of those threats aren't real, but you have no way of knowing if they're credible or not. And, like,
right.
is it worth risking your life to go deliver somebody's, like, McDonald's meal or something? Like, no, it is not. But the problem is, like, it can be very difficult when you're in that situation to figure out, like, am I overreacting or whatever? And so this company reached out to us and they're like, we really need to protect these people. Like, this is happening on our platform. We have a responsibility to stop it. Can you help? And so we hooked in and we were able to catch some of this stuff, which was, like, again, shocking to even hear in the first place. But we have obviously like this very multimodal set of capabilities that are listening to this conversation. And we were finding a lot of stress markers and anger and other things. And, as we were looking into it with this customer, we were looking into it and saying, okay, I'm not seeing any threats of violence, but these people are clearly super stressed. Like, what's going on? And as we were digging into it with them, we actually found out that they were pressuring the driver into doing something fraudulent for them. So, like, for example, I order, I'll call you up as you're on your way to the restaurant, and I'm like, I ordered crab rangoons and they're not showing up in the app, but I definitely paid for them. Like, I need you to go in and get me my crab rangoons. And like, I'm the driver. I'm just like, I can't do that if it doesn't show in the app. And I'm like, I'm sorry. And you're like, no, I paid for it. And you get super upset at me and like you pressure me into it. And we were picking up on that stuff over like $8 crab rangoons, right? And it's just like the people do this stuff. And we would have had no idea if we weren't understanding the emotion and the tone and the sentiment. That was the cue to understand what was going on in the conversation.
Yeah.
That makes so much sense, because every kind of con job usually has, or phishing attack, there's some sort of urgency, right? You're making someone do something outside their normal parameters. That makes total sense. So I guess there's almost like some anomaly detection you do on tone or content or things like that.
Yeah, there's a couple different pieces. Yeah, like so like when trying to detect that fraud, right? Like we start with deepfake detection, which, by the way, because we have this really unique data set where we're able to understand noise and all this stuff, we actually have the best in the world deepfake detector. But one of the things that we are pretty unique in doing is we don't just look for deepfakes, because it turns out deepfake is not quite the same thing as fraud, or rather synthetic voice isn't the same thing as fraud. We now have people using legitimate AI agents to call on their behalf and place a legitimate appointment, right? You might have someone who actually can't physically speak and is using a text-to-speech in order to communicate. So you can't just say, it's a synthetic voice, hang up the phone. You have to actually combine that understanding with what is being said. But if it's a synthetic voice saying, no, I don't remember my security questions, here, let's do this instead, that sounds pretty suspicious to me, right? You can connect those dots pretty straightforwardly.
Yeah. It's just amazing. Like you're saying about, people having agents doing this work. We talk every week about, insert the next tool of choice. Like we joke that we should just rename the podcast like the OpenClaw Weekly, because it's amazing to see all of the stuff that people, to your point, Mike, are starting to just allow their agents to do on their behalf. So that's a really good thing to take into consideration, is just because it's a synthetic voice on the other end doesn't mean that person is trying to sort of do an end run around it. It's just, the world we live in now, right? Whether somebody has a disability or whether somebody's just playing with the latest AI tools and trying them out.
Though from everything that I've seen from OpenClaw in particular, like if I'm having OpenClaw call my bank on my behalf, I probably want fraud detection on top of that. Like
that has happened.
You want somebody to catch that and say, you probably don't want this guy making your phone calls. We just talked a couple weeks ago about, it was, I think it was somebody that does a lot of, I can totally see the person. I can't remember her name. She does a lot of interviews, podcast type content with Google DeepMind. And I think she's a mathematician. And they let OpenClaw try to start its own business for 2 weeks. Gave it a credit card, gave it everything. We had another thing we dug up where somebody, it was in Europe, let OpenClaw run their cafe for 2 weeks. So, great thought experiments, but would I want to do that in real life? What's that?
How was its cooking if it ran the cafe?
It was weird though. You know what? It was funny because it kind of realized that it wasn't a person at some point, because Travis, you remember this? It was trying to hire baristas and setting up, hey, come to the cafe at 12 and we'll talk. And they said at some point it realized that it couldn't meet those people at the cafe, so it shifted all of the interviews to, like, I think a Slack channel or something like that. But you're right. Like, how are you going to interview people when you don't physically exist in that space?
Well, Watson, that was like the Jeopardy playing AI way back in the day.
Yeah.
Oh yeah.
Most people don't know Watson wrote a cookbook. They actually retrained it on a bunch of recipes, and they had it. Unfortunately, IBM decided to like, hey, let's get some professional chefs to like interpret the recipes and gloss it up.
Yeah, I think you just try it.
Well, what's fun is they have.
Oh, sorry,
and then
Mike.
they said,
you're cutting out just a little tiny bit there.
Am I back now?
Yeah, that's better. Yeah, sorry. Go ahead.
Okay. So they had it try to generate all these recipes, and then they asked it, can you also, just for fun, generate a few cocktails for us? And the problem is, it had trained on recipes, and recipes center on a protein. Therefore, all of these cocktails centered on a protein. There's one, in fact, called the shrimp cocktail. There is a like apple grilled chicken gin one. There is a bourbon steak. None of them are good. I did try them in my youth, and I regretted each one, but it was an interesting experience, to be sure.
It's like you're 12 again with no. I dare you to drink this.
Exactly.
What's in it? Just try it. Oh, that's awesome.
Yeah.
One of the things that we talked about was, I think, like our audience, I'm speaking for our audience, so this could be completely wrong, but I would suspect that a lot of them, when they hear the term AI, they immediately think just LLMs, right? Like that's generally what most people think about. And I was wondering if you guys could tell us, because we were talking about sort of the complexity and the challenges you have around voice. Like what's the difference, architectural or whatever you want to kind of share with us? Like what's the difference between what you're building and what happens in an LLM that most people would be using probably on a daily basis now? Can you kind of walk us through that?
Yeah, absolutely. So there's kind of like a technical difference, and then there's sort of like a philosophical difference, right? So from the technical difference, which like I can talk about all day, is that we focus, for those latency reasons that I was talking about earlier, as well as that like richness of representation reasons, we focus on a large ensemble of different models that are all targeting different use cases and then combine their representation together, right? So like if you're putting something in a big foundation model, it is really powerful and it is really general. And you can like give it an audio file or give it something and then ask it a question, and it'll go poke around in the data, run its attention weights across all of the inputs, and then generate a response. And it can do so with a huge amount of generality, right? Like it's very impressive. But one of the problems that you can run into, and you've probably had this experience, is that those models will hyper focus on certain things or certain aspects and then kind of start to run with those. And so you don't very often get a like completely holistic understanding of what was input. You will get an answer to your question. Sometimes it's right. But like you're not going to get like, okay, what's everything that's going on with this input that I've given it? And then like, what can I do with that after? And so what we do is like, we'll run up to 100 different models on a voice conversation that's input into our system. And we can run that in real time as it's happening. And we'll generate various things like kind of what's the emotional profile of what you're saying right now? Like what's your cadence? What's all of these other things, right? Tonality, what's your audio environment? Are you in like a like quiet room on a like high fidelity connection or high fidelity audio equipment? Or are you like calling in on an 8 kilohertz like Mulan coded voice line from a bus, right? Those two things mean very different things. And so like if you're just asking like, hey, like what did this person say? Like you're transcribing it or whatever, you're going to miss all of that context. So we're running all of these models in parallel from this ensemble because we have a prior of like, you need to know all of these different things about a voice conversation in order to fully understand what's going on. So we're bringing like a ton of priors into that analysis. And because we're doing this huge ensemble of a bunch of different models, and it's not all different types of models either. It's like we'll have over a dozen different transcription models that can run on a single conversation. And some of them are like slow but very general and can mostly work in most situations. Some of them are like hyper focused to medical terminology, or some of them are hyper focused towards gaming chat or other things like that. And we'll pick and select between these models about which one is doing the best job, getting the most accuracy, which is the most appropriate for the situation. And then we combine all of those outputs together into a big representation of the whole conversation that you can kind of base everything else off of. So instead of just like asking our system for the answer to a question, it's we're going to tell you everything that's going on, and then you layer the analyses on top. And because you're starting from that very, very rich base of information, you get much higher quality and much more deterministic and reliable results from those analyses than you would just like sticking an audio file in and asking a question and hoping for the best.
Yeah, that's
Gotcha.
really cool.
So you're kind of getting away, like solving the noisy info problem by having a bunch of fine-tuned, tailor-made, specific models pick out specific features that you've analyzed as relevant or useful for these cases, and then softmaxing over that maybe at the end or something like that, and combining that into like a big picture.
Like not even necessarily like softmaxing over it, but more just like kind of like packing a lot of this stuff together into one representation that is very compact but very informative. So almost like creating a like very, very dense and semantically relevant representation of the conversation that you can then layer a bunch of extra models. It's almost like the kind of like unsupervised learning stuff that people used to be really obsessed with before LLMs became all of the thing about with AI. And it's just like, okay, you just pump a bunch of data into this, and your models will figure out how to like auto encode this or something, and you'll end up like with this kind of bottleneck, very, very rich representation layer that you can then build basically any model on top of, and it's going to do a good job even with relatively few examples, because you have trained to build that good understanding of the data. We're sort of doing that for voice conversations.
Yeah, that's really cool. Kind of a follow-up to that, because I know when we were chatting before, you did mention that you're running, I think, the majority or maybe all of this on AWS. And again, I think because we talk about AWS, it's all Travers and I spend our lives doing. I shouldn't say our lives, our day jobs doing. It depends how much time you want to sit in front of your computer. But I was just wondering, like, what's the mix of sort of custom built stuff on AWS versus AWS services? I think people would be interested in like, without the detail, but like, are you building everything from scratch, or are you leveraging AWS services to build this stuff? Like, can you give us an idea of what it might look like behind the curtain a little bit?
Yeah, absolutely. So once again, kind of like, and you'll sort of sense a theme from this. It all comes back to those constraints that voice operates under that a lot of other kinds of media don't. And so with voice, those latency constraints are extremely, extremely important. It's not just latency though. It's also like total end-to-end latency. There's also, for like a real-time voice conversation, jitter itself and predictability is very important, right? And so stripping out different layers of abstraction, even if they're very valuable layers of abstraction, if those layers of abstraction can add either latency or even add jitter, even if they're fast, like they're somewhat unpredictable, then you can end up with, what you want to be a steady stream of information for a back and forth conversation, turning into a big burst of packets and then nothing, and then a big burst of packets and then nothing, and then it's very jittered, even if the overall average performance is very high. And so the result of that is a combination of low-level technologies and a lot of redundancy based on AWS scale, right? So like, how do you do this well is one, removing layers of abstraction. Like, we run a lot of stuff directly on Linux boxes with GPUs.
On EC2.
Right? Okay. Exactly, right? And we'll have auto scaling groups and we'll load balance between them and stuff like that. But a lot of it's like very, very low level. It's like, give me a Linux box, give me a GPU, and then pump the data through that. And some of our models will run in Python if they're non-latency critical, but some of them like will go down to C, because like it turns out allocating memory can have a variable amount of delay in that, and like that almost never matters. Like, nobody cares about it. Except if you're doing real-time audio, you do care about that. 0.1% of the time, but you do care about it, and you get enough of those 0.1% together, and suddenly it matters. So it's that kind of really, really low level, which I guess is kind of a boring answer. Like people usually want to hear about like super fancy.
Yeah.
But at the very least, like getting down to that really low level and having full control of your stack is very important. But then on the flip side, the huge amount of scale and redundancy helps you kind of make those good experiences happen as you start to scale in traffic, right? And so what we'll do is we'll have a lot of very intelligent auto scaling policies that'll warm up the instances kind of as we're starting to see traffic flow up and flow down. And so you'll allocate them, you'll load the models into VRAM, you'll start running data through, because there's a ton of like just various queues and caches and stuff that need to be warmed before you start pumping data through it. And if you don't do that, you're going to have like a really bad experience the first time an audio stream hits that new GPU. So like you kind of do all that pre-warming, and we'll scale them up and down based on like kind of preemptively based on that expected traffic. So there's a lot of using just like, again, like standard auto scaling policies and load balancing, but being able to do it across a bunch of different regions and do it preemptively. The final thing is being able to be multi-region and multi-AZ so that you can route to the closest server. Because like with voice, as you might be aware, 100 milliseconds is a huge deal, right? Compared to like if you add 100 milliseconds into a voice conversation, that's immediately noticeable. And so if you want to run everything out of US East 1, then you're going to have a great time for your customers in DC. And you're going to have a awful time for your investors out in San Francisco, whose voice signals are going to have to go all the way to DC and then come back, at least when US East 1 is up. So like you really do have to be very, very distributed and do really good routing to get to the closest box and feedback results.
You know what I find really interesting about that? Like this is really advanced stuff, and you're using EC2. It's like as much as we want, you kind of said it yourself, Carter, like as much as we want to hear all the cool stuff, right? In the end, you're dealing with traditional infrastructure as a service that's been around forever. And you said things like, I think most people will be really familiar with EC2, auto scaling, load balancing, multi-region, multi-AZ. Like these are fundamental best practices in AWS. And you're using them because you have a very specific situation where, to your point, latency is so important that you have to be able to get in there at the lowest level possible to be able to meet the requirements to make your system work and function the way a person, a customer, an investor would expect it to work. I think it's really, we spend a lot of time talking about moving up the stack, and we have this joke. We always start with like, so what AWS news did you see this week? Oh, a whole bunch of EC2s. I don't care about those, right? But it's funny that you've brought it back to this stuff is still really important based on the types of workloads that you might be running. And in your case, and many other people probably, latency is super important, and you got to be able to get in there and tinker with it to get it just right. I think it's great.
Yeah, I think it's not just like the whole stack isn't just about like moving up the layers of abstraction. Yeah. It's having access to all the layers of abstraction, right? Yeah. And like when you want to, you stay high level. And when you need to, you go down really, really deep. Like a lot of our training stack, for example, like we will use SageMaker. We'll do a bunch of like kind of back and forth between Bedrock a lot, right? Like, we'll use a lot of these different capabilities and these tools and all of these high level like capabilities to augment like our training pipelines and our data loading and our data throughput and all of these different kinds of capabilities where, hey, ease of use, agility, and kind of like scale of moving of data, those are the primary things. And you can tolerate a little bit of latency because you're doing training, right? Like you're just trying to cram as many examples in and out of your sort of fine-tuning pipeline as you can. And then you can go all the way down the stack to really, really low level, like, nope, can't use the new operator. We'd better like reallocate everything. Like you can go all the way down there and you're still using the same stack. Yeah. And that's so important to us.
Yeah. Yeah, it's like the old. I don't know if AWS still uses this term, but I've always just remembered is use the right tool for the job, right? And where you can use a service, so you don't have to manage every little piece of it. Then use that service. But if you have a specific requirement, latency, or you need to get in there and kind of fine tune everything, then to your point, you can move down that stack and really kind of get into the weeds. Yeah, very cool. Very cool. Travers, do you have anything else on your list over there that you piqued your interest as we've been chatting?
Yeah, I guess I have a question about how much time you spent messing with FFmpeg over time. I imagine a lot.
Commercial leader of the business, I have not been allowed to ship code for 5.5 years, and I use FFmpeg weekly. So I can only imagine
Nice.
most of our team ends up being overwhelmed by it.
The number one innovation that I think the number one reason I'm an AI believer is that Claude can use FFmpeg. Like that is just like that value prop. It can do that and it can write JavaScript. And between those two things, I'm like, those are the two things that I can't do as an engineer. And between me and AI, like we can take over the world. There's nothing we can't do.
I love it. Yeah, very cool. I've exhausted sort of my little cheat sheet of things that I wanted to talk about. I don't know, Travers, if you have anything else, or guys, if there's like a specific topic you want to dive into here as we wrap up. Like, is there something
you guys
that
remember?
Oh, go ahead, Travers. Sorry.
Do you guys remember what the problem that you were solving on the whiteboard was? Out of curiosity.
Yeah, absolutely.
We do, because we the voice changing stuff. We put together a video where we wanted to showcase how that technology worked, and we thought like, hey, all of these videos of cutting edge tech, there's something like fascinating on the whiteboard behind them. We didn't have like obvious equations around the ML, so we decided to recreate that physics problem on the whiteboard. We almost failed to solve it because we had been a few years since we'd done physics, but we managed to still crack it. It related to like two spinning drums, one spilling sand into the other one, and like how much does the spilling sand rotate the drum that's...
Okay.
This could possibly be useful to anyone, but that was the problem.
Klepner and Kolenkov, the chapter on angular momentum. And yeah, you've got a drum with sand in it, and at time t equals 0, it's spinning, and little holes open up and the sand pours out. And then at time t equals infinity, at what velocity is the outer drum spinning? You know, basic stuff.
just basic. Yeah,
perfectly normal stuff. Yeah.
Isn't there a whole movie sort of around that? Somebody like solves a problem somewhere, and isn't the whole movie based on that?
Talking about Good Will Hunting?
Yeah, isn't it sort of when you guys you said that, I'm like, my brain was like, I'm sure there's a movie about that. That's really cool. There you go. Your origin story is solving a physics problem. I love it. Well, guys, thank you very much. I think this has been great. You've given me a lot to think about, and it's really interesting. Like, I hadn't really thought about the complexities of building solutions focused on voice, and you've really opened my eyes to the subtlety, like we were talking about, like the tone and sort of how that conversation is being had. I think people will really enjoy this, and it'll open them up to, again, just kind of thinking of their own ideas and maybe tackling some big problems. So thanks a lot. I really appreciate the time tonight.
Absolutely. We were super happy to be here. And I think, in addition to understanding like the complexities and a lot of the challenges that come with voice, I hope, kind of the other takeaway people get is like how exciting it is when you solve those challenges. Like we've seen it with images, video, text. Yeah. It's coming to voice too. And that kind of like richness and like latency and intelligence, like those different constraints that mean that like, okay, voice was still pretty tricky to get right. But like we can see how exciting that is going to be and what it's going to be capable of when those constraints do get solved. And we're working on part of the solution. A ton of people out there are working on part of the solution. And I think that's what gives you a ton of motivation is voice AI is cool now. It is going to be so much cooler 12 months from now. Yeah. So I hope that's kind of the other thing people get excited about.
Yeah, it's really cool. There's an author that I often refer to on this podcast, and just made me think of it. Ethan Mollick, in his book, he says something like, just remember, the model that you're using right now is the worst model you will ever use. And it just constantly improving and getting better all the time, right? So I think that's a great way to end.
I similar on the model that you're using right now is already outdated. Get to the new one already at the pace that we're moving. But
Yeah. I have a few that I really like, and I have a few that I love to hate. And every time I go to use them, I'm like, why am I doing this to myself? I should just go back over there. That one's much better. It's going to make my life a little less stressful. So thanks again, guys. We wrap the show up. I'm going to throw another little curveball at you. You can choose to participate or not. We wrap every show up with recommendations. Travers and I, for a very long time, have been friends of really friends. Well, we have been friends for a long. We've been fans, fans. That's the word, of really crappy horror movies, right? Like really bad stuff. So we'll often share movie recommendations. We'll share book recommendations and stuff. Travers, can I put you on the hot seat? Do you have anything this week? Recommendations that you want to share?
I'm excited for something coming out.
Yeah.
There's the. Are you guys familiar with the Backrooms? It's like a ARG horror series about falling into like a parallel kind of weird liminal space that's coming out, I think, this Friday. So I'm excited for that. I saw Mandalorian and Grogu last week, and I can't really recommend it.
Okay, I was gonna ask you about that, and I had a chuckle the other day. Somebody took a picture, it was on Reddit, and take it with a grain of salt. But they're like, I have the whole movie theater to myself for the new Star Wars movie. And it was just like an empty theater. That's happened to me once in my life. It was like, oh man, I don't want to do the math. Probably more than 30 years ago, right? There's too much gray in my beard now. Probably 30 years ago, my wife and I, she was still in school, and I was visiting her, and we decided to go to see a movie. And we walk in, and we had the whole place to ourselves, and it was absolutely fantastic. So even if the new Star Wars movie is bad, if you get to watch it by yourself in a movie theater, I would take that. But I'm glad you told me, because I probably am gonna have to go see it, but I have heard it's kind of Yeah. For me, I'm gonna go back to a recommendation that I've had a couple times. It's a series of books. The first one's called Red Rising, recommended to me from a friend, and I kind of stalled on the second book. I got doing something else and was kind of like, oh, I'll go do that again. And she was bugging me. She's like, so like, where are you? Like, you haven't said anything about the book. And I'm like, I owned up, and I was like, I haven't been reading it. Sorry. So now I joke with Travers that I'm often sleep deprived because I'm spending too much time with Claude. And now I'm sleep deprived because I got started on the second book, which please don't ask me to remember what the title is. But this is like space opera, humanity in space, Mars versus everybody else. What if you're into sci-fi, space kind of opera sort of stuff, lots of sort of nuance in the story, it is well worth a read, and it will make you, well, I guess unless you're doing the audiobook, it'll make you walk away from your computer for a bit. Really good story. Really good.
I can't offer much in the horror genre. My partner's very, very into that, and the furthest I've ever gotten into the space is like Cabin in the Woods, which I would argue is like actually a good movie, and classic. Does not deserve to be in the like crappy horror franchise. There was something that this is like deep nerddom on my part, but there is a online web novel that is a like fanfic rewrite of Pokemon that is trying to like reconcile the logic of what's going on in the Pokemon universe. But for whatever reason, it wrote the discovery of Ditto, the Pokemon that like imitates everything else, as just a straight horror film. So that chapter is just like, you can't and everyone's being replaced, and like it was a true body snatcher, just like was so jarring in that universe, but was actually very well crafted.
That's awesome. You should go back.
Ditto is basically the Thing, if you think about it.
See, again, you guys are all younger than me. I'm like, I don't have any frame of reference for Pokemon or anything. I'm just like, I was off doing other things. But you did make me think, Mike. Even though you're not a fan of horror, if you haven't been made to watch it, you should watch the original Body Snatchers with Donald Sutherland, like 1970 something. It is like a classic old horror movie. Well worth the watch, and it's not really that scary. You know, they didn't make stuff too scary back then. Carter, can we put you on the spot? Enough. You got any recommendations?
Absolutely, yeah. So this is actually one Mike's familiar with. Back in undergrad, we would all get together and we would play video games, and we would almost do like a let's play of it. So yeah, I guess we're streaming on Twitch.
Oh yeah,
so,
he already knows.
Yeah,
and you know, so we all kind of gathered into one of our friends, Kirsten's room to play a game together. And Kirsten's now Mike's wife, and she's really into horror. So she's like, you know, we're gonna play Amnesia: The Dark Descent. If you have by any chance.
Okay.
Yes.
Oh yeah.
And so I was the lucky person to get to play it, and I'm not a like horror lover or anything like that.
Oh, perfect.
And the key was that there was a group of like 8 of us all together in this one dorm room, and we would play for 2 or 3 hours straight, and it was like midnight to 3 a.m. and everybody was tired, and everyone was kind of like getting along and whatever, and we turned all the lights out so you could just see the screen, and we were sort of going around, and it was the most terrifying experience I've ever had in my entire life, because you're going around and you don't have any weapons, like you can't fight whatever it is.
Yeah.
And you're sort of like going through, and it's sort of this, you know, your own little like Dante, journey into hell, and you're like finding all of these like horrifying things, and you're being chased around this stuff. And it has this really great mechanic where it's got a sanity mechanic, and the sanity mechanic is that in the dark you start to go crazy, and like when you see like weird stuff, your sanity goes down. And as your sanity goes down, you start to make more noise and start to, you know, like see things. And so you, the player, start to panic and start to like run around and stuff like that. And of course you're making noise. And of course you're like running out of hiding and stuff like that. And you're more visible. And so the things that are after you are more likely to find you when your sanity meter goes down. And to restore your sanity meter, you have to get back into the light. Well, you're visible in the light. And so if they're chasing you and you're running low on sanity and you're like looking around, or they're chasing you, you're like, you see them and your sanity goes lower. And so, you know, and then you're like, oh, get to the light. And then you get to the light, but then they can see you more easily and they'll chase you better. And so you kind of like spiral. And it's like it's this really great dynamic to be doing at like 2 a.m. when you're just like, I just can't do this right now. Like I absolutely can't do this. And then the tragedy of this game, and the reason why it came to my mind when you said bad horror, is that when you are not in that state, because I replayed it one time by myself, just being like, wow, this is so amazing. You know, when you play it at like 4 p.m, when it's bright out by yourself, you know, you're like totally chill or calm or whatever. It's like the silliest, like, you know, the monsters are all on a little track, and like, you know, they have all these sorts of mechanics that you can cheese very easily, and you can beat the game, and you're just like, what was that? So it's like either the most incredible horror experience you will ever have, or the cheesiest, like,
awesome.
You know, what was this awful little video game?
There was a great segment where like you're just slightly in water, and there's a monster that like is going to leap out of the water and get you, and literally the game designers, it's just a sphere. Because the whole point is like you're never supposed to see it. It just like comes up and goes. So they didn't bother making an actual monster. But if you like move the camera underwater in the right way, you can see like it's just literally a sphere that is chasing you. Like it is this dichotomy of like if you get in the right mindset, as Carter said, it can be a very spooky thing. But it is also very goofy.
With the group, right? The group psychosis takes over. Everybody's just feeding off of everybody else's energy. But if you're playing by yourself in the mid-afternoon, you're like, what? This isn't scary. That's awesome. Well, thanks again, guys. I really appreciate the time. This has been a lot of fun. We talked about birds. We talked about AI. And we wrapped up with a whole bunch of possible horror movies to watch and a book here or there. So great, guys. Thank you very much. It's been a pleasure. And you get to listen to our other crazy song, which, Travers, I finally fixed. So I don't know if you've heard this
You
one.
fixed it. Okay.
I fixed it. You get to hear the outro music. So thanks again, guys. Bye for now.
Software used to cost $1 million.